Hello everyone. We're back today to talk to you a little bit about quadratic functions. Okay, so hopefully you remember that a quadratic function is going to be a polynomial function of degree 2. Okay, so in its most basic form, f of x equals x squared, that's quadratic. When you graph it, its parent function is a parabola, okay? Just something simple like that. We like to see a parabola in vertex form when possible. Okay, so your y or your f of x of the form a, x minus h, the quantity squared, plus k. All right, because then that's useful to tell us transformations of this original basic parent function x squared, in that we would know the vertex of our parabola is at hk. All right, the a out here in the front can tell us about if it's a stretch or a shrink, or if there's been a reflection. Okay, and then h is going to tell us any kind of a horizontal shift, whether, in other words, if it's going to the left or to the right. And then your k is going to tell us whether or not you have any vertical action going on. So k tells us if you're moving up or down. Okay, so vertex form of a quadratic is pretty useful for us. Okay, so there's some just basic information to start. There's a couple of types of situations I want to go over with you as far as quadratics go. One extra section that is not covered in this video is how to complete the square, where we start with a quadratic, I don't know, maybe something like this, and I ask you to rewrite it into vertex form so that you're able to tell me about the vertex and whether or not that vertex is a minimum or a maximum point. That's covered in a separate video, and that's called completing the square. Okay, and I just didn't want this video to get too long, so therefore I made a separate video about completing the square, so you'll have to look that up after this. Okay, so let me clean this off a little bit here. Pen is making quite a mess for us today, but that's okay. Bear with me a second, just like at school. All right, so here's your first problem situation, okay, or example. It says find the vertex and the axis of symmetry for the given quadratic, okay? So let's say we have something like f of x equals 6x minus 3x squared minus 5. That's what you start with. That's a function. So you look at that and you say, hey, you know what? I know that's quadratic, but it seems to me a little disorganized. So first up, we want to rewrite so that we can get this in descending order. Okay, so that would be the first thing I'd take care of. So basically we're switching around the x squared and the x term. So we're going to say a negative 3x squared, a plus 6x, and then a minus 5. Okay, so we're just rewriting in descending order. All right, so this particular way we're going to do this is that we're going to first find what we call the line of symmetry or axis of symmetry. So when you're drawing that lovely parabola, wherever it might be, the axis of symmetry is that line that's going to cut it right down through the center so that the left side and the right side of your parabola matches up. And there's a couple of ways to do this. The way I'm going to show you involves us identifying the A, the B, and the C in your quadratic, just as if you were going to do quadratic formula. Or not, but the same A, B, C as in the standard form of that quadratic. Okay, so to find that line of symmetry, okay, we're going to do something where, a couple ways I can show you. x equals negative b over 2a. Okay, so we're going to start with that. So in this situation, you've got negative 6 over 2 times negative 3, negative 6 over negative 6, which is just 1. So that tells me that for this particular quadratic, I have an axis of symmetry at x equals 1. Okay? So if I were to actually try and sketch this, I don't have this all the way worked out, but we'll give this a shot. Okay? At 1, I have a line of symmetry. One kind of got ran over. Okay? So then to find the vertex, okay, we know it as HK from what we had before, okay, in a vertex form. H and K is the vertex. Okay, so this X on the line of symmetry is the same as the H in our vertex. Okay, so at this point we know the vertex is going to be on that line of symmetry at 1 something. So we got to figure out what that K value is going to be. Okay, so K is going to become an f of 1. In other words, take that 1, plug it back in that quadratic and see what you get. Okay, so we've got negative 3 times 1 squared, 6 times 1, oopsie, here, 6 times 1 minus 5. Okay, so negative 3 plus 6 minus 5. So 3 minus 5 looks to me to be negative 2. Okay, so that's going to be our K value. So now I know the vertex will be at 1, negative 2. Okay, just like that. Okay, so then the question is, if that's the case, then is that going to be a minimum or maximum? Okay, well, how do you know? Well, remember A holds the secret. Okay, so I have a negative 3 here, so what's that tell you about your parabola? Well, it should turn over. Okay, so our parabola, and again, I'm just rough sketching this, looks something like this. We have our axis of symmetry, and then we have our parabola. Okay, I can also go ahead now and I can rewrite in vertex form. Okay, our A is negative 3. Okay, and then if you fill in your H and your K, x minus 1, the quantity squared, minus 2, that should be the equation for our parabola. Okay, all right, so that's a way to find that vertex and the axis of symmetry. You have to know to use x equals negative b over 2a to start. That gives you your axis of symmetry. That x value is the same as h in vertex form. Same, because the vertex is going to hit that axis of symmetry. Okay, then if you simply plug that 1 in, or your x back in to your original quadratic, that'll kick out your k value. Then you can rewrite in vertex form using the a from back here at your original. Okay, all right, now the other type of problem I wanted to look at with you is if I give you some information and I ask you to find the equation of the quadratic with a couple different clues. I don't know where I found this pen, but it is being difficult to erase today. Now, yeah, there we go. I think we're good. Okay, so here's your second type of problem for the quadratic section. Let's suppose you are given the vertex and a point on your parabola. Okay, and the question says write the equation of the parabola. Okay, all right, so for my example, I'm going to give us a vertex at 5, -1. Okay, and our parabola is going to pass through the 1.-37. Okay, so that's like your clues, and you're supposed to come up with this equation. Okay, so think about it. What do you know? We know several forms of parabolas, equations, that we could work with. All right, it seems like for some reason I'm liking vertex form a lot. Okay, so if we think about this, what does the vertex represent, the ordered pair here, in terms of this equation? Okay. Well, I think I hear you from class. You're saying H and K, and if that's what you were thinking, thumbs up, you got it. Meanwhile, this point over here is going to represent an XY. It's just one of the many points that would make up that parabola. All right, well, I have X, Y, K, H, everything but A. Cool. So let's plug everything in. We can solve for A, and I think we're being right on our way. All right, so let's see what happens here. I have 7 equals A times the quantity, -3 minus 5, quantity squared, plus K, well, K is -1, so I could have just said minus. All right, so let's see if we can simplify here. So inside the parenthesis, -8. So -8 squared would be 64. So 64A minus 1 equals 7. Boy, I don't know who made up this example. Kind of messy numbers there, huh? All right, so let's solve this for A. So we'll make up 1, or add 1, sorry. 8 equals 64A. Divide both sides by 64. So this will be 1/8 over here. So A equals 1/8. Okay, well, what's that do for us? Well, if we know the value of A and we know the vertex, we can write the equation of our parabola, sure enough. Okay, so filling in, Y equals 1/8 times X minus 5, the quantity squared, minus 1. That would be the equation of the parabola that we're looking for. It tells us, since the A is positive, that our vertex would be a minimum point on the graph. Okay, and then I think we're all set and ready to go. All right, I hope you found this helpful. If you have questions, be sure to bring them to class. Thank you for watching. Have a great day.